welcome back. We're going to look now at a special way to graph lines that slope. Lines that slope go at an angle. They can't be straight up and down, can't be flat across. If they slope and they have an angle to them, then they will have two intercepts with one possible exception. If the line happens to pass right through 00, then it will not have two different intercepts. It'll have both the x-intercept and the y-intercept at the origin, called 00 by its coordinates. But here's what we've got. Intercepts are special points. Very special, and also usually a little easier to work with. They always have 0 as, here's the important part, for the tricky ones, at least, but most of the time we don't say at least, one of their coordinates. Could be that x is 0, it could be that y is 0. In most cases, with a sloping line, you'll almost always find that it has an x-intercept and a y-intercept. The other coordinate will be 0 on those intercepts. The intercept is an ordered pair, so it's got to have the comma, the parentheses, and one of them written as 0. You can't just say, oh, the intercept's 4. And that doesn't help. Even if you say the y-intercept is 4, people might understand that you're talking about b equals 4 and it's the point 0, 4, but the intercept is a point, so we have to find a point when we're doing that. Now, how do we find the value of an intercept? I'm going to do that over here. To find the value of an intercept, so to find the intercept's coordinates, well, one of them is going to be 0. They may tell you x is 0, find the other value. When you're doing that, you're looking for a y value. You're calling that, I'm looking for the y-intercept. It's a value for y that touches when the other thing, x, is 0. They may say, find me the x-intercept. We don't do that as often, but it's still useful. You're looking for the x-intercept. You're looking for an x value when the other thing, y, is equal to 0. So we're always following this idea. Intercepts are special points where at least one of the coordinates is 0. This at least is because every once in a while, you'll run into it where both coordinates are 0, passing through the origin, and a little bit different than some of the regular cases. But how do we find the intercept's coordinates? Well, what I would do first is I would substitute 0 in for the coordinate. Now, which coordinate? Not both, and not randomly choosing it. That equals 0. There's one of them that equals 0. They tell you that x is 0, you use x is 0. They tell you y is 0, you use y is 0. If they tell you you're looking for the x coordinate, you're looking to find x, the y must be 0. If you're looking for the y-intercept coordinate or the y-intercept, you're looking for the y value when x is 0. So one of them is 0. So you got to figure out which one is 0 and substitute that in. Solve for the other coordinate. Now, I'm going to write coordinate, but then I'm going to do some more after it. I'm going to write coordinate. And I'm going to put a pair of parentheses because you don't need this, but it's true. The other coordinate's number value. It doesn't help me to say, I know x is 0 and y is the letter y. I need the number value for what y is there. So then I'll have the two together to make up my values that are going to go in as my ordered pair and help me find the point. Now, you don't have it when you just say, oh, I just found out y is 4, I'm done. No, this is also an important part. You have to say, write the intercept as an ordered pair. I can tell you 4 of the 5 things that will be in that ordered pair. The other one is the number that you just found, and that changes from problem to problem. One of the things will be first an opening parenthesis. The second one is either 0 because you know x is 0 or the number you just found. The third thing is always a comma. The fourth one is either 0 because you knew y was 0 or the number you just found for y. And the last thing is always going to be closing parentheses. So you got 2 parentheses, a comma, and a 0 in there. That's 80% of what you're going to have in your answer. Therefore, I'm justified in a 5-point problem if you give me the answer that says, find the y-intercept, and you find 4 to be the value of y for the y-intercept, and you give me 4, you gave me 20% of the answer. You didn't give me either parenthesis, you didn't give me the comma, you didn't give me the 0. So that's worth like 20%. That's an F. So we got to get the entire ordered pair figured out here. Now, what we're going to do to solve for an intercept, we're going to put it to work in a valuable way. If the line slopes and doesn't go through the origin, and I'll go through that a few times as we're working on this, if the line slopes and doesn't go through the origin, we'll be able to find 2 different intercepts. We will plot those 2 points, and because there's only an x and a y that can be equal to 0, those will be the only 2 points we can ever get using intercepts, and we'll pass the line through those 2. No self-correction. If you make a mistake, it's just going to be wrong, and the only way to fix it is to, number 1, recognize that it's wrong. How would you do that? I don't know. And then find what you did wrong and do it right. So there's no self-correcting on this, but it's very quick for a lot of people to get through these. So let me show how we're going to graph using intercepts. I'm going to use color on this regularly. Graph a line. The other way we learned was the 3-point T-chart method. This is going to be using intercepts. So what happens? Basically, if we have x present and y present, we have enough variables to make a line that's going to slope, and we can't let it go through the origin, so it's got to have x on some term, y on some term, and a number that's not 0. And if that's the case, we can graph using intercepts. We may not want to, but we can. And I'm going to go through that in another video in a few minutes. I'll be done with a couple of these, and then I'll go into the details. So what we're going to do, I'm going to pick up the green, and it's going to be how I start. And this tells you how we're going to find the coordinates of an intercept. So number 1 is find one of the intercepts. That's an ordered pair. And then you're going to graph that one. So you don't say, oh, I just found one. That was so easy. Let me go find the other. Yeah, we do need to find the other one. But you don't find one and rapidly go find the other one. You go from creating the intercept, turning it into a point, because that's what you're going to find is it's an ordered pair, and you graph that point. Now you go reload. I'm going to reload by switching to red. You're going to find the other intercept. This up here tells you how to find an intercept. So if one case you let x equal 0, the other case you let y equal 0. I don't care which one you do first, but you need them both. So you're going to have to go find the other intercept. Frequently in class, there's a question, should I find x first, should I find y first? It absolutely doesn't matter, but you find one of them first, and you find the other one later on. One of them is the x-intercept, one of them is the y-intercept. That's all true. The y-intercept has a lot more uses later on. So if I had to say one's more important than the other, the y-intercept is more important than the other. The reason I'm going for blue right now is because the last step of this process is to pass a line through it, and we know Connect Math uses a blue line when you're done. And that is to pass the line through both points. They are intercepts. But if you'll notice, if I say pass the line through both points, we can use that in lots of different kinds of ways that we're graphing lines. So I'll keep that consistent. Let's get to some. So what I'm looking at here is 4x plus 6y equals 12. I see it has x, I see it has y, I see it has a number that's not 0. That means this will allow me to graph with intercepts. So I'm going to go ahead and do that. First, I'm going to let x equal 0. That's a choice of mine. Alphabetically, it comes to x first. So I do that, and this is really beneficial because it's the first point I'm going to find is x is going to be 0, so it's going to have 0 first. It's going to give me the y-intercept, and it's something I can use a lot later on. So I go through here, and I have 4. I'm about to put 0 in for my x with parentheses, so it's not 40, plus 6y equals 12. Okay, 4 times 0 is 0, plus 6y equals 12. At this point, some students might say, duh, 0 plus 6y is exactly the same as 6y, and they are correct. Some of my students are really sort of concrete, and that's okay, because then if they say, wait, I got to get rid of the 0, you can subtract 0 if you really want to. I'm not going to laugh at you or anything like that. And it'll do what we've been doing. This is 6y that doesn't change, and 12 minus 0 is still 12. When we divide by 6, we know exactly what y is. Y is equal to 2. We're not done with this yet because I need to know what's the ordered pair for green, and that is 2 goes in for y. What's x? Green x is 0. So that needs to go on my number line, or rather my coordinate axis. At this moment, I'm not sure how big the graph has to be, so I'm going to try leaving some extra space and pushing it out to 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. If there's graph paper waiting for you, or if you're on Connect Math, it's already there. And then your next move would be to take 0, 2, and graph that intercept. So 0, 2. I don't go across at all because I have 0 for x and I have a positive. That means go up 2 and make my green y intercept. Same process in red, finding the other one. So I can't let x equal 0 again. I'm going to let y equal 0. So when I hit the y, I'm going to put parentheses around the 0. 4 stays with x plus 6 times 0. It's not 60. It's 12. 6 times 0 is 0, so 4x plus 0 equals 12. You can do minus 0 and minus 0 if you want, but this time I'm going to say 4x plus 0 is the same thing as 4x, and this is another way people might do it. 4x is 12. 12 is my target, but I have multiplication by 4. The opposite or inverse operation is to divide both sides by positive 4. X equals 3. So I'm ready to do what it says in step 1. Now I'm in step 3. Find the other intercept. 3 is my x, so that goes first. And 0 is my y, so that goes here. And I'm going to get this point 3, 0. 1, 2. So you start at 0 and you take 1, 2, 3 steps. Remember, the first one isn't a step. That's just getting you started at 0. I have that for my ordered pair. So now I could pass the line through that goes straight through and establishes my 2 intercepts. Now I want to take a look at this one if I did it the old-fashioned way, which is 3 points and it should make the same graph. So if I took it as 4x plus 6y equals 12. Isolating the y first, let's get rid of the 4x right here. We're going to go minus 4x minus 4x, also known as adding 4x to both sides, so that's completely gone, and I get 6y. For reasons that are coming up, I'm hoping you get used to putting, what I have here is the next thing should have an x on it. That's a negative 4x. And the other thing I have is a positive 12, so I'll go with plus 12. So that's what 6y equals. I don't want what 6y equals, I want what y equals. I'm going to divide all 3 places, all 3 terms throughout the equation on both sides of the equal sign by the 6 and reduce my fractions. 6 over 6 is 1, takes me straight to y. Negative 2 over 3 is coming up now. This is divide by 2, divide by 2. Reduce 4 over 6, you got 2/3. It's still negative. Negative 2 over 3. Behind it is the x. Plus, luckily, 12 over 6 is 2 over 1. That gets me 2. So here we go. From what we've worked on before, I'm going to put in 0 for my x. And that gets me that y equals negative 2 over 3 times 0 plus 2. Negative 2 fraction 3 times 0 will get me 0, or negative 2 times 0 divided by 3 is all 0 plus 2. Gets me 2. Look at that. Right there. Now the next one I would use would be blue when I'm doing the 3-point method, and I'm going to say this has a jumper of 3, so I'm not going to go 0, 1, 2, I'm going to go 0, 3. I'm going to find out what that is. Y equals negative 2/3 times 3 plus 2. You can cancel the 3's, negative 2 plus 2. You can get negative 6 divided by 3 is negative 2 plus 2, or use your calculator to see that negative 2 plus 2 takes the whole thing down to be 0. It won't always work exactly this way, getting the 2 intercepts in the first step. In fact, it rarely does. But that gets me the 2 points that I just had. Now, if this was a 3-point T-chart method, I'd also put in 6. And that should also be on the line. So, y equals negative 2/3, here comes parentheses around a 6, plus 2. It's negative 12 over 3, which will make negative 4, plus 2. Or you can do your calculation, negative 2 fraction 3 times 6, then plus 2. Or you can cancel, dividing by 3 is 1, dividing by 3 is 2. In any case, negative 4 plus 2, they work against each other, subtract and get 2. In this case, it's strong on the negative, and you get 6 negative 2, which means a point that I don't even go anywhere near when I use intercepts is also on there. 1, 2, 3, 4, 5, 6, and down 2 would be right there. If I did it with my 3-point method, it would get that point right there. I'm going to make that a hollow point. I'm going to let this stand as the 2 intercepts. That process will go on every time. Automatically, getting the intercepts will find 2 points on the pathway and set up your line. So we'll stop here, as you've seen how that works, and I'm going to follow it up with several examples in another part. So we're going to graph a few more lines using intercepts. Steps are over there. You can take a peek over there anytime you need to, but I'm going to go right through the process with the colors and get these done. First, we're going to graph x plus y equals 5. So, it's got an x, it's got a y, it's got a number that does not equal 0. It's going to work. It's going to give me something. I'm going to let x equal 0. So I'm going to go with 0 in for my x. You can put it in parentheses if you want, but 0 plus y equals 5. For those of you that are concrete, I'll subtract the 0 and scratch it out. I'll see that y equals 5, and I'll get the ordered pair where y is equal to 5 and the x is 0. That's got to go on a graph now. So 0 for x and 5 for y. Let's make sure that my graph paper reaches the 5s. Okay, here we are. We'll go to my graph paper. 0, 5, time to go across, but it says go 0. Time to go up or down, it says positive 5. 1, 2, 3, 4, 5. Above the origin, straight up to 0, 5. Now we do the other one where we let y equal 0. And so when y shows up, I'm going to put 0. Otherwise, I'm going to go with x plus, here's my 0 for y, 5. You can subtract 0 off both sides if you want. Those that understand x plus 0 is the same as x, I'll help you out with this one. There it is, x is 5. Ordered pair, which has parentheses on the outside and a comma in the middle. The x must be 5. It's an intercept, so the other one, which is y, must be 0. I got 5, 0. 1, 2, 3, 4, 5. Put the point down. Those are the 2 points that are intercepts, but they're 2 points that are on my line. So I'm going to shoot the line through them. Back to some of the things we've done in the past. We can see that this one is going downhill, goes above the origin, and it misses quadrant 3. That's how that one works. We were fortunate the way that worked out, but we'll keep going. Another one. 2x minus 4y equals 12. And we need to graph that. We're sketching the graphs. We're not making perfect graphs that everyone can rely on down to, tiny little specks being perfect. But that's what the graph looks like. That's a sketch. All right, so this is 2x minus 4y equals 12. Making the 12 look a little more 12-ish. And we're going to let x equal 0. We're going to let y equal 0 eventually. What I've always done is I've put plus in front of any sign that you call minus, and it's 2x plus negative 4y equals 12. And that will help with some of the things coming along. Here we go. We're going to let x equal 0. Let x equal 0. So 2, here's my parentheses in 0, not 20, 2 times 0, plus negative 4, y equals 12. That's 0. 0 plus negative 4y equals 12. Those that want to subtract zeros can do that. If you know 0 plus negative 4y is negative 4y, you'll see why it becomes negative 4y equals 12. We're going to divide by something here. That's a negative 4 sitting in front of y. I need a plain old positive 1y, so I must divide by negative and 4. Both sides have me divide by negative 4. The opposite of negative is positive. 4 over 4 is 1. That's why I get the letter y only. And over here, my 12 divided by 4 is 3. It's got a single negative, so that's an odd number. I get negative 3. Ordered pairs have a comma in the middle and parentheses on the end. Y is negative 3. The other one, x is 0. Of course, x is 0. So now I know my y is going to have to reach out to 3. Let me go out to like 6. If you miss, you just extend your graph paper, but I actually have reason to believe that it should reach out to the 6s. You're not generally drawing your own graph paper. It's usually there for you. So let's get out to the 6s. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I did not know what was going to happen with the reds, but I'm what we call ready for it. Here we go. Let y equal 0. The other one, after I let x equal 0, I got to let y equal 0. I do it in a different color. Oh, forgot the green. Step number 2, graph that intercept, 0, negative 3. Across, don't do it. Negative 3 is down, 3 right there, 0, negative 3, my y-intercept. Now I'm ready to continue, letting y equal 0, go find another intercept. So when I see the y, I'm going to put parentheses around the 0. 2x plus negative 4, parentheses around my 0 for y equals 12. 2x plus, that whole thing is 0. And that equals 12. And if you wanted to subtract zeros, you can, but those who know 2x plus 0 is the same as 2x. We'll divide by 2. Signs are important. Remember, if you don't know how to do your signs, I want to borrow money from you, so tomorrow you can pay me back and we'll be even. X is positive 6. Parentheses, comma, x is positive 6. The y is 0 because it's an intercept. It also says it right there. And therefore, I'm going to go to x is 6. So I start at the origin. To the right, 1, 2, 3, 4, 5, 6. And then 0 going up and down lets me stay right on the axis. Each intercept will be having a coordinate that is 0 and will therefore be sitting on an axis, and I will pass the line through there. So I'm going to start erasing these after a little while. I'm going to have time for you to look that one over. Particularly, I'm going to erase the top one, but I'll have you take a look at what we've got there for our instructions. I'll read through them for you again. We're going to find one of the intercepts. I do it in green, and I usually let x equal 0. We're going to go find out exactly what that ordered pair is and put it on the graph. Now we go back and get the other one. I do it in red. I usually have it being let y equal 0 because I need both before I can graph them. When both those are graphed, each at their own time, on the graph paper I have 2 dots. That's all I'm going to get from intercepts. I use that to pass the line straight through it. And as long as you didn't make any mistakes, it's going to look great. If you did, it's going to feel great, but it's going to be wrong. Because there's that thing, I think I told my class before, do you know what feels exactly the same as being right? Correct, being wrong. So you can't feel wrongness. You're going to believe what you did. So this does not have a backup plan for you. All right, now we got this one. Y equals 5 over 2x minus 5. Now I'm recognizing, while I'll talk a little bit about it, I'm probably going to need some more space because of that fraction, for one thing. So I'm going to take this down. But you can stop, you can reload, you can do whatever you want with the video to get back at that one. This one's just got no reason for me to cramp it into small space. Cram it in there. So no. But according to what I said, and I wasn't lying or trying to trick you, if it's got a y and it's got an x and it's got a number that does not equal 0, it's going to be able to be graphed with intercepts. So we're going to go ahead with what this says. Let's let x equal 0. So when we see the x, we'll put parentheses around 0. Y equals 5 over 2 times 0 minus 5. Now, of course, I'm more of a plus negative 5 guy myself because we know how to add integers. We're not really into the whole subtraction of integers thing and hope they are integers. Well, 5 times 0 divided by 2, that'll be 0. Or you'll see that 5 fraction 2 times 0, then you're going to have to do plus negative 5. What's that all mean? It means y equals 0 plus negative 5, y equals negative 5. We're done getting our algebra to compute for us what we have here for an intercept, which is parentheses around a comma with coordinates on each side of it. The y was negative 5 and the x was 0. So that's ready for my graph. And that wasn't too bad. And so if the other one's not too bad, then this is going to be the great way to go after getting these things graphed. So I see I got to reach at least a 5. I'm going to start with 5. If I need more later, I'll pump it up to larger. I'll just expand it. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And the green one is 0, negative 5. So I'm not going across due to the 0. I'm only going downward because of the negative. 1, 2, 3, 4, 5. I remind you, you're counting steps. So the first step is number 1. Touching down on the origin is not the count of 1. All right, we got the other thing to do. Sounds easy enough. Let y equal 0. Yeah, that's pretty easy. Where the y is, I'll put 0. I could put it in parentheses. It turns out I don't need to. If I have 0 in parentheses with nothing else going on, it'll eventually come back to 0 equals 5 halves x. That 5 better be visible because we're going to need it. Plus negative 5. Okay, so now my job is to determine the value of x that makes that true. On this one I did arithmetic. It was a calculation. My calculator could help me do it. This one is an equation. It's got stuff on both sides of the equation, and I got to figure out what x is equal to. We have to solve this equation. Now, we've already worked in class on how to solve an equation like that, and if you're awesome at it, then this is going to pose no threat. But pretty soon I'm going to show you how we make a decision to find the easiest way for each of us to decide to graph any line we have to graph. So we're solving this thing for x. I need to get the x alone. That means I need to add 5 to both sides. I need to add positive 5 here so I can scratch out that negative 5. I need to add positive 5 to my 0. This will scratch out and won't even be written, and 0 plus 5 is 5. 5 equals 5 halves x. So I'm on my way toward the answer. If you know about the reciprocals and you're familiar with multiplying both sides by 2 over 5, and the 5 is 5 over 1, you can go ahead and find the answer that way. Not going to stop you. A lot of teachers teach it as the only way to go. Well, what this is a 5 over 1, and I want that to equal 5 over 2 with space in front of my x, because I'm going to multiply through by the lowest common denominator on both sides. I'm going to multiply through the LCD is 2, which goes as 2 over 1. So now I can hear the groans, even though we're not live. What we got to do is we've got to multiply this by 2 over 1 and that by 2 over 1. So I'm going to multiply this by 2 over 1 and this by 2 over 1. And those are my only terms. There's no plus sign saying here comes another term, so give me another 2 over 1. We got the term on each side. This gets me with 5 times 2 to get me 10 over 1 times 1, which is 1. And here the 2's are definitely going to cancel. Or we can get 10 over 2. But 2 divided by 2 is 1, blue 2 divided by 2 is 1, and we're going to get that as 5x. So 10 equals 5x. That's now not having fractions anymore. We'll divide each side by 5. Doesn't matter that the x is over there. You definitely have had me teaching you. We got to get the x alone wherever it is. Divide each side by 5, because that's 5 times x. We need to divide by 5 to get there. X equals 5. Nope. Don't. I got that thing wrong. Oh, man. The purple marker of shame is not here, but we do have, what's this guy's name? Oh, Purple Kiwi. My bad. We got to fix that. We're going to leave the mistake in. I could almost say my students taught me to make that mistake, but nope, I still shouldn't do it. This thing needs to be the number 2. 5 over 5 is 1 for the x. I'm awesome on that, even though it had an x. And somehow I did 5 divided by 2 and got a 5. Why did I subtract? I don't know. That was bad. That's correct. X is 2. We're still doing the red one. Ordered pair. And x is 2, so that's first. And then it's an intercept, so the other one is 0. And yes, all the way back here it said y equals 0. So now I got this point 2, 0. 1, 2 for the x is going to the right, nothing for y, so I do that, and I have my point. Look at what happened there. you're going to always wonder if I made that mistake on purpose. Because what I'm trying to say is, if we do this with intercepts, there's a lot of work to be done. Some stuff we're not so good at, some stuff that takes more time, some stuff that gives us a headache. All that kind of stuff can be avoided if you know that this has y equals something times x plus -5. How about we set up a t-chart with x's and y's. And do you know what the 3 x's would be here? How about 0, not 1, jump with a 2, 2. Now that you see we're jumping by a 2, 2 more is 4. And if we did that with 0, 2, 4, we would get the 3 points. This would be the first one. That would in fact be the second one. And the third one would be up here. And we'll get it that way. What I want to do is in the next video show you how to decide which is the easiest way to get the job done. And we'll do that shortly. See you soon.